Okay, in this video we're going to be talking about the properties of logarithms, and we're going to start out with the product property. And here's what the product property says. If you have a log of base, any base, of two things being multiplied together, we can actually split this into the log of the same base of m plus the log of the same base of n. Therefore, the log of a product can be split into the sum of two logs. Number one says to condense into a single logarithm using this property. So we're going to do this backwards. If we have the log of two things being, two logs being added, we can take those arguments and actually multiply them. So log base 3 of 9 plus log base 3 of 5 would be the log base 3 of 9 times 5, which would be 45. Log base 10 here of 6 plus log base 10 of x minus 3 can be split into combined into a single log by multiplying the arguments, and you're left with 6x minus 18. Let me zoom in just a little bit more. This also works for log base e's. So if you have the natural log of 4x squared plus natural log of 3x to the third, this would be natural log of 4x squared times 3x to the third. Then we're going to combine that using rules of exponents. 4 times 3 is 12. Count your x's, 2 and 3. That gives you a total of 5 x's. So 12x to the fifth. Now we're going to work these backwards, expand using that same product property. So with log of 72, just a reminder that 72 could be written as 9 times 8. So that'd be the log of 9 times 8, which would be the log of 9 plus the log of 8. So this rule works forwards and backwards. The natural log of 9/10. We could just find two fractions that multiply to give us 9/10, maybe 3/2 and 3/5. So we could write this as the natural log of 3/2 plus the natural log of 3/5. Log base 5 of x squared minus 4. Now, first thing I noticed about x squared minus 4 is we could factor that, and that is difference of squares, factors into conjugates. X times itself gives you x squared, 2 times itself gives you the 4. So this is log base 5 of x plus 2 times x minus 2. So we could split that into log base 5 of x plus 2 plus log base 5 of x minus 2. Next up, your quotient rule. Just backwards of what we just did, the quotient property says log base b of m divided by n. Well, to multiply, to do the log of a product, we add. So therefore, to do the log of a quotient, we subtract. This would be log base b of m minus log base b of n. So the log of a quotient is the difference between the two logs. So now let's use that rule and let's condense into a single logarithm. So natural log of 96 minus the natural log of 6, we could write as the natural log of 96 divided by 6. And then we can reduce that. That'd be the natural log of 16. Log of 8x to the 10th minus log of 4x squared would be the log of 8x to the 10th divided by 4x squared. And we will reduce that as well. That'd be the log of 8 divided by 4 is 2. 10x is on top, 2x is on bottom, subtract, and you're left with 8x's. So that'd be the log of 2x to the 8th. Next one, the log base 7 of root 40 minus log base 7 root 5 would be the log base 7 of root 40 over root 5. And we can divide these since they are both radicals. That'd be log base 7 of root 40 over root 5 would be root 8. And you could simplify that into 2 root 2 there as well. Okay, now we're going to expand to the exact same thing except for backwards. So the number 8 we could write, first off, we could write that as like 16 over 2 is 8. So that'd be the log base 3 of 16 minus log base 3 of 2. Again, a difference or a quotient can be written as the difference between two logs. Natural log of 3/4 would be the natural log of 3 minus the natural log of 4. And then the log of x minus 7 over x plus 1 would be the log of, and put it in parentheses just to be safe, x plus 7 minus the log of x plus 1. And again, that's your quotient property. And then the last property here, let's talk about the power property. Power property says if you have the log of something being raised to a power, that power can actually be moved down front. And you can write this as n times log base b of m. So anytime you have an exponent, that exponent can be moved. Number 13, we're going to do it right backwards. It's already been moved, so now let's put it back. We're going to condense it to a single logarithm. 3 times log of 6 we can write as the log of 6 to the third. And that can be simplified and written as a log of 216. This 1/2 again can be moved up. It's a coefficient right now. Move it up front or up top as an exponent. That'd be 81 to the 1/2 power. And a reminder that a 1/2 power is the same thing as a square root. So that'd be log base 4. The square root of 81 is 9. Number 15, again, this thing out front can be moved up back into an exponent. That'd be natural log of 4 to the x minus 1 power. Number 16, we're doing the same thing except for backwards. Anytime you have an exponent, it can be moved down front, so that we could rewrite this as x times log base 2 of 5. This one, let's rewrite it. Since it's a cube root, we're going to write that as 2x plus 1 to the 1/3 power, and then move it down front. That'd be 1/3 times the natural log of 2x plus 1. And then finally, log base 6 of 1/64. We could write this as an exponent just to demonstrate this rule. I know 8 to the second power is 64, so 8 to the negative 2 would be 1 over 64. Then that negative 2 can be moved down front. That'd be negative 2 times the log base 6 of 8. Okay, on the next problems, it says using the properties of logarithms. What we're going to do is use all those properties we just learned to condense these. Condense each expression to a single logarithm. So number 19 here. First off, take care of all exponents. Anytime you have an exponent, or excuse me, a value out front, we're going to move it up to an exponent. So we can write this as log base 4 of 9 squared, move that back up top, plus that'd be log base 4 of 2 to the third. We can clean that up. That'd be log base 4 of 81 plus log base 4 of 8. And again, anytime you have two logs being added, we can combine that into a single logarithm by using the product rule. This would be log base 4 of 81 times 8, which would be log base 4 of 648. Okay, number 20. The log of 80 minus, now we have a 2 here that can be moved back up top. So we now have the log of 80 minus the log of, let's go ahead and clean that up, that'd be 16. Your quotient rule says anytime you have the difference between the two logs, you can write it as a quotient. So it'd be 80 over 16 or simply the log of 5 to clean that up. Number 21. All coefficients out front, let's move them up to powers. This is the natural log of PQ raised to the third plus the natural log of PQ squared raised to the fourth. So first set of parentheses, let's raise everything to the third power. That'd be the natural log of P to the third and Q to the third plus the natural log of P to the fourth and Q to the eighth. Power to power, we multiply. Now to combine these, we're going to combine them by using the product rule that says if you have a log plus a log, you can combine the arguments by multiplying. So let's count our p's. You have 3 here times 4 more, that'd be p to the 7th. 3 q's and 8 q's gives me q to the 11th. Number 22. A few different ways you can do this here. You could distribute the 1/2 if you want to. Let's go ahead and start inside the parentheses and combine those. So we have 1/2 times log base 5 plus log base 5. To combine these two logarithms, we're going to again use our product rule. A log plus a log you can combine by multiplying the arguments. X to the 6th, x to the 3rd gives you x to the 9th. Next up, we can, anytime there's a number out front, we really don't need this anymore. Anytime there's a number out front, we can move it up top into an exponent, so we can move it up here. And we could write this as log base 5 of x to the, power to power, we're going to multiply. You could write that as the 9/2 power. Or you could write it as a radical, that'd be log base 5 of the square root of x to the ninth. And that square root of x to the ninth we could simplify, but those are fine. You could leave it either way. Number 23. First, let's take care of the 2/3 and the 2. Let's move them back up to exponents. So 2/3 power there and a second power there. So it'd be the natural log 64 to the 2/3 power. Bottom number's a radical, top number's an exponent. Always do the radical first just to make it cleaner. Cube root of 64 is 4, and you still have your second power, so that gives you 16. So it'd be the natural log of 16 minus the natural log of 8 times 8 is 64. The quotient rule says to subtract two natural logs, you can combine them with a quotient 16 over 64. And then you can reduce that. That'd be the natural log of a fourth. That'd be the cleanest way. Next one, number 24. Let's again go inside and take care of the inside first. So this 1/9 is being raised to the 1/2 power when you bring it up. You have now -2 times the log of 15 plus the log of 1/9 to the 1/2. Again, that's the square root of 1/9. You can take the square root of the top and bottom separately, so that'd be 1/3. Next up, a log plus a log. We can combine with the product rule, so we're going to multiply our arguments. 1/3 times 15 gives you 5. We're now going to move this up to an exponent, and that'd be log of 5 to the -2 power. To make a negative exponent positive, bring it to the bottom. That'd be the log of 1 over 5 to the second, or 1/25. Number 25. Again, we're going to start inside the parentheses, cleaning up. So you have the log of 72 minus 1/3 parentheses. The 2 comes up top, and that gives you the log of 16 plus the log of 32. Let's stay inside of parentheses, and let's do a log plus a log is going to be our product rule. To add these two logarithms, we're going to multiply, and that'd be the log of 16 times 32, which is 512. Let me try that again. That coefficient can now be moved up to an exponent. That'd be 512 to the 1/3 power. And again, to raise something to the 1/3 power, that would be a third root of 512, and we can do that. You can check it. That is 8. So we now have the log of 72 minus the log of 8. The log minus the log, we're going to subtract those by using the quotient rule. That'd be 72 over 8, which would be the log of 9. Number 26. First off, let's take care of all of our coefficients by moving them to the exponents. That'd be log base 3 of a to the 3/2 power minus the log base 3 of 16a squared to the 1/4 power. Let's clean this up right here. We've got to do 16 to the 1/4 power and a squared to the 1/4 power. 16 to the 1/4, the fourth root of 16 is 2. A squared to the 1/4, multiply your exponents is going to give you a to the 1/2. So therefore we have log base 3 of a to the 3/2 minus log base 3 of 2a to the 1/2. Log minus a log, we're going to use our quotient rule. That's going to be log base 3 of a to the 3/2 over 2a to the 1/2. That would be log base 3. Let's clean this up. The 2 on bottom stays. A to the 3/2 on top, a to the 1/2 on bottom. Subtract those exponents. 3/2 minus 1/2 is 2/2, which is a whole. So you have a whole a on top. So log base 3 of a over 2. Okay, next up. Now we're going to expand. We're going to do the exact same thing, just backwards. And again, we're doing all of this just to give you extra practice on these rules. So the log of a quotient. Step number 1, we're going to write this as two separate logs. That'd be log base 7 of x plus log base 7 of y to the 3rd. Then take care of any exponents. That'd be log base 7, of x plus, let's bring the exponent down front, 3 times log base 7 of y. That's expanded completely. The natural log of a quotient can be written or split as the natural log of the top minus the natural log of the bottom. And then any exponents we're going to move down front. That'd be 3 times the natural log of m minus 7 times the natural log of n. And you can put those in parentheses so it doesn't look like just a bunch of letters sitting there. Number 29. First off, take care of that square root. Let's write it as an exponent. This would be the log, in parentheses, of a to the third b to the 1/2 power. And since that's not a sum or difference, we can just raise each of them to the 1/2 power. So that'd be log of a power to power to multiply. That'd be 3/2, and b to the 1/2. Let's now split it by using our product rule. That'd be the log of the first, which is a to the 3/2, plus the log of the second, which is b to the 1/2. Then bring your exponents down. That's 3/2 times the log of a plus 1/2 times the log of b. Number 30. Everything's being raised to the 4th power, so let's go ahead and raise everything in parentheses to the 4th. C squared to the 4th would be c to the 8th. D to the 4th on bottom is d to the 4th. So that would be the log base 4. You have a quotient now. Log base 4 of the top minus log base 4 of the bottom, d to the 4th. Exponents down. Let's bring the 8 down front. That's going to be 8 times log base 4 of c minus 4 times log base 4 of d. Okay, number 31. Again, everything in parentheses being raised to the second. Since you have no pluses or minuses, you can go ahead and square everything in parentheses and multiply when you're doing powers to power. So p to the third to the second be p to the 6th, q to the 4th to the second be q to the 8th. Now you have the natural log of a product, so we're going to split it into the natural log of 25 plus the natural log of p to the 6th plus the natural log of q to the 8th. So the product rule works on if you have 3 or more products as well. Next up, we're going to bring all of our exponents down. Now you could have left this as 5 to the second and brought down the 2, or we can just write it as a natural log of 25. The 6 comes down front, write it as 6 times natural log of p. The 8 comes down front, and that'd be 8 times the natural log of q. 32. So on top, let's write that cube root of x as an exponent. That'd be log base 2 of x to the 1/3 power over x squared plus x. Now let's do something with this x squared plus x. That will factor if you, that's one option where you could write that as x times x plus 1. And you could even do this. You could simplify this x with this x to the 1/3. And I think I'm going to do that just for some extra practice. You've got x to the 1/2 or x to the 3/3 on bottom. And the reason you can do this is there's no plus or minus attached to that. So that's going to give you log base 2. When you subtract the 3/3 here and the 1/3 on top, you're left with nothing on top. And you're left with x to the 2/3 here and then the x plus 1. So now that could be written as the log of a quotient would be the log of the top minus the log of the bottom. And that'd be base 2 there. And the bottom was x to the 2/3 times x plus 1. Now also on bottom you have a product here. So you're going to have, now let's talk about this first though. Log base 2 of 1. 2 to what power is equal to 1? If you were to look at that, if you were to simplify this logarithm, 2 to the 0 power is 1. So log base 2 of 1 is actually equal to 0. You don't even have to put that. Just bring down the negative. Now you're going to have the negative of a product here, or excuse me, of a sum of 2 logs. So you're going to put that negative out front. So the log base 2 of x to the 2/3 plus log base 2 of x plus 1. And I'm going to close my parentheses there. That minus goes with both of those logarithms because the minus was out front when you split it, so you need to put the minus out in front of the whole sum when you do split those two. Now here's a mistake that a lot of people make. Log base 2 of x plus 1, they want to split that using the product rule. However, the product rule works when you have a log plus a log. This is a log of two things being added. It's not the log of a product, so therefore you cannot use the product rule on that. So that is now finished. Final answer.